entire business of mathematics learning revolves around numbers. And therefore, to have a very sound understanding of numbers is not just good, but is a must. Let's start classifying numbers and let's learn more about properties of numbers. This is a very basic class on numbers, and therefore this would entail mere introduction of certain things. And then as we chug along, we will add finesse to our understanding of numbers. We'll refine our understanding, we'll add more properties, and so on and so forth. But let's get past the basics first. So this session is intended at giving you nothing humongous, but very basic things about numbers. Some things that I expect you to know, I'll quickly reiterate those things. About a very basic classification of numbers. I hope you understand what natural numbers are. Natural numbers are 1, 2, 3, etc. These are natural numbers. Now, if you add 0 to the set of natural numbers, you get what's referred to as whole numbers. That means 0, 1, 2, 3, etc. This bunch of numbers would be referred to as whole numbers. And then you have what's called integers. Now, integers are plus minus 1, that means plus 1 and minus 1, plus minus 2, plus minus 3, etc. along with 0. Along with 0, these are integers. This is a very basic classification, and when mankind started, when civilization emerged, that's when, these were prominent numbers. In fact, it started with 1, 2, 3, 4, and 0 got added much later. And as you understand from the history of numbers, 0 was a gift from India given to the community. And then, of course, it got further refined, further classified. We started conceiving of negative numbers like minus 1, minus 2, minus 3, and we began to assign meaning to those numbers. Now, this was the most basic classification of numbers. And then, as the society evolved, there were complexities, and they figured out that we just don't need integers alone. We also need numbers that are combination of integers. Now, combination of integers as in numbers of the form p by q. Numbers of the form p by q, where p and q are integers. I denotes an integer. I denotes the set of integers. So then, ratio of two integers, p and q, ratio of two integers, p and q, also required a name. The ratio of two integers, p and q, which could itself have been an integer or a fraction. Things of this sort. A formation of this sort is referred to as what's called a rational number. This is called a rational number. A number of the form p by q, where p and q are integers, is called a rational number. However, there is a limitation to this. P and q can assume any set of values, except that q cannot be 0. Because if q is 0, all of you understand, and I hope by this time have been able to relate to the fact that division by 0 is not a mathematical operation that is legal. Therefore, q cannot be 0. Other than that, p and q can assume any integer values. These are the integers that are relevant. P could be 0, p could be plus minus 1, plus minus 2, etc. Q, however, can be anything except 0, because division by 0 is illegal. So numbers of the form p by q, where p and q are integers, the name given to such numbers is rational numbers. These numbers are called rational numbers, p by q, etc. Now, for example, 5 by 7. Is this a rational number? Yes. This is an integer, this is an integer. This is a rational number. 11 by 4. Is this a rational number? Yes, it's a rational number. Ratio of two integers. Minus 6 by 3. Yes, this is also a rational number. By the way, some rational numbers could also be integers. For example, look at this. Minus 6 by 3, which is minus 2, which is an integer. So some of the rational numbers can also be integers. Now, rational numbers, of the form, let's say, 8 by 24. This is a rational number. This is a rational number. 8 by 24. Right? This is an integer. This is an integer. This could be in its lowest form expressed as 1 by 3. Right? 5 by 7. It's already in its lowest form. There is no further cancellation from the numerator and denominator. 18 by 26. That's 9 by 13. This is the lowest form. 25 by 35. This could be written as 5 by 7. Right? Now notice one thing. All rational numbers, 8 by 24 for example, written as 1 by 3. 5 by 7, already in its lowest form, where there is no common factor between 5 and 7 that we could cancel. In this case, there was a factor 8 common between 8 and 24, and therefore we could cancel that and get to the lowest form of the rational number, which is 1 by 3. 18 by 26, which is 9 by 13. Again, we could cancel the factor 2 from the numerator and denominator and get this in its lowest form, which is 9 by 13. 25 by 35. This is also a rational number, and there is a factor 5 common between the numerator and denominator, and cancelling that led to 5 by 7. And 5 by 7, no further cancellation could take place. Which means, at the end of the day, any rational number, p by q, any rational number p by q could eventually be expressed in a manner that there is no further factors common between p and q. And eventually when you convert a rational number into a number in which the numerator and denominator have no further common factors, then, for example like this, 1 and 3 have no further common factor, 5 by 7, 5 and 7 have no common factors, 18 by 26 reduced to 9 and 13, 9 and 13 have no common factors other than 1 of course, 25 by 35 reduced to 5 by 7, where the only common factor between 5 by 5 and 7 is 1, which means eventually every rational number, I repeat, every rational number could be reduced to a ratio of 2 integers in which the 2 integers, one sitting in the numerator, one sitting in the denominator, have no factor other than 1 in common, right? Once that happens, that means once you express a rational number in the form p by q, let's say it's given to you in the form p by q, for example 8 by 24 or 18 by 26, you could reduce it to a form, say p prime by q prime. Every rational number could be reduced to a form p prime by q prime such that the numerator and denominator have no factor other than 1 in common. Eventually, when you reduce a rational number to a number in which the numerator and denominator have no factor other than 1 in common, then we say that the numerator and denominator are co-prime. What are co-prime numbers? Co-prime numbers are numbers that have only 1 as the common factor. For example, 1 and 3, are they co-prime? Yes, because the only common factor between them is 1. 5 and 7, are they co-prime? Yes, the only factor common between 5 and 7 is 1. 9 by 13, are they co-prime numbers? Yes, because the only factor common between 9 and 13 is 1. 5 by 7, once again, 25 by 35 could be reduced to 5 by 7, where 5 and 7 have only one factor common, that is 1. So eventually, when you reduce a number to a form, when you reduce a rational number to a form in which numerator and denominator have only 1 as the common factor, that means when the numerator and denominator are co-prime, when the numerator and denominator are co-prime, then the rational number is said to have been reduced to its lowest form. So every rational number, either it's already in its lowest form, for example 5 by 7, it's already in its lowest form, no further cancellation can occur. 1 by 3 is already in its lowest form, no further cancellation can occur. 9 by 13 is already in its lowest form, no further cancellation could occur. But 8 by 24 is not in its lowest form, it's still a rational number because they are the same. But there is scope for further cancellation from the numerator and denominator because there are factors common. So once you reduce a rational number to a form in which the numerator and denominator become co-prime or relatively prime, co-prime or relatively prime, that's when we say that the rational number has been reduced to its lowest form. So every rational number is either in its lowest form already, as is 5 by 7, or could be reduced to its lowest form. As you can see, 8 by 26 could be reduced to its lowest form, 9 by 13, where there is no further cancellation that can occur between the numerator and the denominator. Alright, so once you understand what a rational number is, that means essentially ratio of any two integers. Ratio of any two integers, as long as the denominator does not become 0, is a rational number. Denominator becoming 0, I repeat, is a illegal operation. Division by 0 is not permissible in mathematics. And therefore, ratio of any two integers, when the denominator is not 0, produces a rational number. And every rational number could be reduced to its lowest form, in which the numerator and denominator have no factor other than 1 in common, and that's when the numerator and denominator are called co-prime or relatively prime. That's the lowest form of expression of any rational number, right? Okay, once this settles in your head, right, the expression of a rational number, the expression of a rational number in its lowest form, starting from the ratio of two integers, which may or may not have factors common, you must also understand another implication of a rational number. A rational number, like I said, in very basic terms, is ratio of two integers. One integer divided by another integer. Ratio of two integers produces a rational number. Ratio of two integers will produce a rational number, and the two integers may or may not have common factors, but eventually could be reduced to a form in which the numerator and denominator have only 1 as the common factor. Now, there is a decimal representation of rational numbers. In the decimal form, decimal representation of rational numbers. What's a decimal representation of rational numbers? You could have a terminating decimal, for example. Terminating decimal. Terminating decimal is like 5.361. Can this be expressed in the form p by q, where p and q are integers? Yes, this could be written as 5361 divided by 1000. All of you understand this. So that's a terminating decimal. That's a terminating decimal, which also is a rational number because it could be eventually written in the form p by q, where p and q are integers. And then there could be what's called non-terminating but repeating, non-terminating but repeating form of representation of a rational number, which is like, for example, if I said 5.33333333. Now the question is this a rational number or is this not a rational number? Is this a rational number or is this not a rational number? The only question to be addressed is if it can be expressed in the form p by q, where p and q are integers and q is not 0, then it's a rational number, right? So now 5.3333, for example, which is not terminating but repeating. See, these are not terminating. This is going on till infinity. Non-terminating but repeating decimal. This could be written as 5 1 by 3, which is 16 by 3, which is the ratio of two integers p and q, where q is not 0. And therefore 5.3333 is also a rational number. The character that it has is, it's a non-terminating, the decimal portion does not terminate but repeats. The decimal portion does not terminate but repeat. Now, let me give you a little more involved case of a rational number where you want to express that in the form p by q, where p and q are integers. Say if I had 5.62626262, etc. Now this is not terminating. This is going on forever. 626262, but it's repeating. The 62 is repeating itself. How do I know if it's a rational number or not? The moment I can write it in the form p by q, where p and q are integers, q is not 0, then I can conclude that it's a rational number. This 626262 is till infinity. Forever it goes. It's an infinite chain of 62s. So it's not terminating but repeating. And I can guarantee you that every non-terminating but repeating decimal representation will reduce to ratio of two integers no matter what, and therefore will be a rational number always. This, for example, let me call this as x. 5.626262 forever. Let me call that as x. Now, what's 100x? 100x is going to be 562.62626262. That's 100x. Etc. This goes on forever. Now, let me subtract this minus this. I hope all of you understand this. X is this. 100x means the decimal will shift 2 places to the right, leading to 562.62626262. Now what's 100x? 100x is this. Let me say 100x minus x. That means this minus this. That's going to give me like a 99x. Now 562 minus 5, that's 557. And 0.626262, etc. with this 0.626262, etc. forever will get cancelled. And therefore the right hand side is simply 557. And now what's x? X then is 557 divided by 99. That's x. 557 divided by 99, that's x. Which is the original number. Which means the original number could be expressed as ratio of two integers p and q, where q is not 0. Does it make sense to all of you? Yes, it does. Therefore, this number is rational or irrational. This is a rational number. This is a rational number because it could be expressed in the form p by q, where p and q are integers and q is not 0. Now, having said this, just to give you another example on the same, non-terminating but repeating. Non-terminating but repeating. Say I have 525.313, 313, 313, etc. It's non-terminating but repeating. See, 313, 313, 313. It's repeating itself. I want to figure out if it's a rational number or it's not a rational number. Let me call this x. Now this time what I do is the repeating portion I want to bring to the left of the decimal. That's what I want to do. The 313 is the unit. This is the unit that's repeating itself. This unit I want to bring to the left of the decimal. What would I then do? I would multiply this by 1000. If I multiply this by 1000, then this one unit 313, which is repeating itself, now belongs to the left of the decimal. So then we have 1000x equals 25 313.313, 313, 313, etc. Now, that's repeating itself. Do you realize that? Now 313, 313, 313, 313, 313, 313. That's repeating itself. What I would now do is 1000x minus x. So that makes it 999x. Now 999x. Realize that the portion to the right of the decimal here and the portion to the right of the decimal here is identical. So those portions will cancel each other, isn't it? This 313, 313, 313 and this 313, 313, 313 would cancel each other. And therefore, what I am left with in the numerator is 25, 313 minus 25 divided by, so this is 999x. That's 999x. X therefore again realize is 25313 minus 25 divided by 999. Divided by 999, which is an integer divided by an integer and therefore should be looked upon as a rational number. So conclusion, every rational number in its decimal representation will either be a terminating decimal, or if it's a non-terminating decimal, see this decimal portion is not terminating. If it's a non-terminating decimal, it would be at least repeating. It would be repeating itself again and again, time and again. So then that's the decimal aspect of every rational number, which could be written in the form P by Q. P and Q are integers, Q is not zero. And in the lowest form, the rational number could be written as the ratio of two integers that have no more factors other than one in common. That's when they are referred to as coprime, right? Now, some very basic properties of rational numbers. Some very basic properties of rational numbers, very quickly. And I want you to check these properties yourself. Feel convinced about these properties independently. Sum of two rational numbers or difference of two rational numbers. A rational number added or subtracted from another rational number. Sum or difference of two rational numbers. Sum or difference of two rational numbers will always be a rational number. Will always be a rational number. You add two rational numbers, you will get a rational number. You subtract two rational numbers, you will still get a rational number. Product of two rational numbers will always be a rational number. Ratio of two rational numbers . Ratio of two rational numbers will always be a rational number. These are some of the properties I want you to explore independently and feel convinced that this is true. However, a rational number to the power rational, what according to you would be this? A rational number raised to the power rational number. Now we cannot be sure about what this would be. This could either be rational or it could be irrational. For example, if I had 1 by 2 as a rational number and I raise it to the power 3. This is a rational number raised to the power 3, which also is a rational number. Right? I hope you realize 3 is a rational number because it could be written as 3 by 1, which is ratio of 2 integers. So this is 1 by 8, which is a rational number. So a rational number to the power rational number could be a rational number. However, a rational number, let's say 2, raised to the power another rational number, half. Half is a rational number, 2 is a rational number. But we'll be able to establish very shortly that 2 to the power half is not rational. Is not rational. Which means a rational to the power rational may or may not be rational. We cannot be sure of that. However, the sum or difference, the product and the ratio of two rational numbers will be guaranteed a rational number. Now, so by this time, you understand what rational numbers are, and therefore, it's also important to understand what rational numbers are not. Right? In my next session, very shortly, you will have a quick idea of what would not be rational numbers. Right? This much for this session. Await the next session. Thank you.